So now that you've reached the end of your program, you're going to be programming this Capstone 3000 machine. So I just wanted to go over some of the key things that you're going to be doing. You're going to have different pucks. This is a tall plastic, short plastic, tall metal, short metal, and bad puck. These are going to be loaded into your system, and after you load them, you're going to have a cylinder that's going to push these pucks out onto the dial. The cylinder is going to be pneumatic. You're going to have digital outputs as well as digital inputs for this cylinder. The digital inputs will tell you whether the cylinder is extended or retracted. After you put the pucks in there and you put it out onto the dial, you're going to have to rotate that dial. The dial is rotated using a servo drive. So you're going to have to program the servo drive in order to rotate to the next station. The next station will determine whether it's metal or plastic by use of a capacitive sensor. At this point on the dial, you'll have to use this laser sensor, which is an analog sensor, to determine the height. If it is short or tall, once it's there, you're going to go to the next station. You're going to have to pull that off and polish the part. Right here, you're going to have a VFD motor that is going to turn this polisher, and you're going to have pneumatic parts, pneumatic cylinders, in order to extend and close the gripper. Each one of those cylinders have an open and a closed sensor, so those will have to be used in your program. After you finish from the polisher, you'll go back to this back side, and you'll have a Cognex camera where you'll have to inspect and view QR codes to determine if the part is good. After the camera will rotate, the dial will rotate around to the robot. The robot's going to come over here and use a PLC output to turn on a vacuum and pick up the part. Now, as it's been moving through, you're going to have multiple parts on the dial. So the dial will be full of parts. When it gets to here, the robot needs to pick it up, but it also needs to know the status of that part. Is that part good? Is it metal? Is it plastic? Is that part tall or short? Has it been polished? Did it pass inspection? Does it have the right QR code? At that point, you need to have kept all that in your whip and know what that part is. Once you know what that part is, the robot will pick it off and sort it to reject, tall or short, and metal or plastic. So you'll have tall plastic, short plastic, tall metal, and short metal. So one of the difficult things is that whip, so make sure that you keep track of those parts as they're going around the dial. One of the things that you're going to have to program is this Epson robot. Members of our advisory committee have asked that students have to figure some of the equipment on your own. So it needs to be noted that for safety, this robot has two states. First state would be if I break the light curtain, it'll go into a controlled stop. That means that the servos will decelerate and it'll lock the brakes and stay there and not move until the light curtain is reset. The second state would be an emergency stop, which would be pressed by, if you press the emergency stop button, that'll instantly and immediately shut down the robot and not allow any movement. The e-stop here is on the panel, and these light curtains here go through the mirrors and it comes back to the receiver over there. So it needs to be noted that if you have troubles with the light curtain, that the mirrors have to be aligned correctly in order to make it work properly. So if I break the light curtain like this, the lights over there will change state and equipment will instantly come to a stop. Your servo motor is going to have to be homed. So here's an example showing you of this home routine. Another thing that will be required of you is to log the data from the Capstone 3000 up to a server, either using Ignition or Kepware or some other software to properly log the data. Inside the cabinet, there will be a Compact Logix PLC and a Micrologix PLC. Make sure that you select the Compact Logix PLC for this Capstone 3000 project. There will also be safety, such as a e-stop relay, a light curtain relay, and safety contactors. It'll be your responsibility to not only notice the safety relays, but also learn how they work. So at the end, on your final presentation, you'll be able to explain to anyone how these safety relays work and the importance of safety in an integrated system. On the front of our panel, we have an HMI. You're going to have to program that HMI from scratch for yourself. Make sure that when you do your HMI, that this would be something that you would be proud to show your employer. I don't want something that looks half done. Make sure you put your full effort into your HMI and all of your code. So when it's done, you have a professional, fully developed program and fully developed interface. At the end of your Capstone project, you will be required to do a presentation as well as a report. Make sure that you're prepared to answer what safety category this Capstone 3000 has and to explain why you gave that. It's important because in the field, you will be doing risk assessments and you will have to design and program machines to correct safety category levels.